Hello, everybody. So we're going to continue with Module 11, Lesson 11.4, Writing Inequalities in the 6th grade Go Math Middle School textbook. We are on page 321 of the textbook. And the essential question basically is, how can you use inequalities to represent real-world constraints or conditions? So let's look at the Explore activity. Using inequalities to describe quantities. An inequality is a mathematical sentence that shows a relationship between quantities that are not equal. In meaning not, equal being equal, so not equal, right? And we can use symbols in the table to write inequalities that describe quantities with many values. All right, so when we see this symbol, we know that that means less than. And some word phrases would be fewer than, below. This symbol is greater than. And some word phrases are more than or above. Now this one is called less than or equal to. And some word phrases you would see with that is at most or no more than. Okay. And finally, we have this symbol, which is greater than or equal to. And the word phrases you'll see in that situation is at least or no less than. So let's go ahead and look at a couple and let's practice. So the lowest temperature ever recorded in Florida was -2 degrees Fahrenheit. So they want us to graph this temperature on the number line. All right, well, -2 is right here, right? All the negative numbers are to the left of 0. And in B, the temperatures 0, 3, 6, 5, and -1 degrees Fahrenheit have also been recorded. And so we have to graph those. All right, well, let's just find those on the number line. 0 degrees, 3 degrees, 6 degrees, 5 degrees, and -1 degree. All right. Pretty straightforward, right? Now, how do the temperatures in B compare with -2? Well, here's -2, and everything that we just plotted in section B is to the right. Well, if the numbers are to the right of another number, that means those numbers are greater. So they're all greater than -2. We can also say they are all to the right of -2. Okay. All right, so D, how many other numbers have the same relationship to -2 as the temperatures in B? So in other words, which numbers are all greater than -2? Well, my goodness, that could go on forever, right? We call that an infinite number, right? So we can say an infinite number of possibilities. Because any number to the right would be greater than -2. Suppose you could graph all the possible answers to D on a number line. What would the graph look like? All right, so we'd have one at 1, another one at 2, 4, 7, 8, so on, so on, so on. And so basically, it would be an array that does not include -2. Okay. Okay, so how can we represent the solutions or all the possible answers to D? Well, X, some number, has to be what to -2? Greater than. Okay, we're not including negative 2, so there can't be an equal. So it's all numbers greater than negative 2. All right, so let's look at page 322. And so how do we graph solutions of an inequality? And so a solution of an inequality that contains a variable is any value of the variable that makes the inequality true. For example, 7 is a solution of x is greater than negative 2 since 7 is greater than negative 2. And that's a true statement. All right, so graph the solutions of each inequality and check the solutions. So here we have some number is less than or equal to negative 3. So we could also say some number is no more than negative 3. All right, so draw a solid circle at negative 3 to show that negative 3 is a solution. Okay, you see I have a solid circle. And then we're going to shade to the left of negative 3 because the variable, the less than symbol is pointing at the y, so the numbers have to be less than negative 3, so we're going to go to the left. Check your solution. Well, we can choose any number on here to see if that's true. Is negative 4 less than or equal to negative 3? Yes, so it's a solution. Negative 5 is less than negative 3, so it is also a solution, and so on. All right, in this one, we have m is greater than 1. So we want all numbers greater than 1. 1 is not greater than 1, so we can't include 1. So we're going to have an open circle on that one. But then we're going to shade everything to the right. Okay, and you see that it is array, and it doesn't include 1, so it's an open circle. So let's check it. Is 1 less than 2? Sure it is. Okay, because 1 is to the left of 2. So number 1. Inez says you can rewrite 1 is less than m as m is greater than 1. Yeah, that's true. The inequalities are going to have the same solution. Okay, but it's just being switched around. So in our number line, 2 is greater than 1, and 1 is less than 2. 3 is greater than 1, and 1 is less than 3, and so on. Okay, so it doesn't, she's right. You can rewrite it as m is greater than 1. Right, 2. How is x less than 5 different from x is less than or equal to 5? Well, when x less than 5, 5 is not a solution. So it would not be included in the graph. In x is less than or equal to 5, 5 is a solution and is included in the graph. Okay, so when I say not included in the graph, that means it would be an open circle on the graph. In x is less than or equal to 5, it would be a solid circle because 5 is a solution. All right, let's continue. 323. All right, so let's graph the solutions of the inequality t less than negative 4. So find negative 4 on the number line. Okay, here's negative 4. And it says less than or equal to, so we're going to have a solid circle because negative 4 is equal to negative 4, right? And now the symbol is pointing at the t, so we want less than. anything to the left of -4. Okay. So everything to the left of -4 would work. -5 is less than -4. -6 is less than -4, and so on. Okay. All right. So how can we write inequalities? We can write an inequality to model the relationship between algebraic expression and a number, or to represent certain real-world situations. The variable in an inequality can represent an infinite number of numbers. Okay, and we see that in this graph, right? This inequality has infinite number of negative numbers that would be possible to make the solution, the statement true. So here, A, write an inequality that represents the phrase, the sum of y and 2 is greater than 5. Well, the sum of y and 2 is y plus 2. Is greater than, we would use the greater than symbol, and greater than 5. So in this, we see that the solution has to be greater than 5. So in this case, we know that, in a sense, we're going to treat this like an equal sign, right? And so we're adding to y, so we're going to subtract the 2 from both sides. So subtract 2 from both sides, and y has to be greater than 3. Why does y have to be greater than 3? Well, if I put 3 in for y, 3 plus 2 is 5, but 5 is not greater than 5. So all my answers must be greater than 3. Does 4 work? 4 plus 2, 6 is greater than 5. So that works. So we're going to have an open circle at 3 because 3 does not make it a true statement. But 4 does, 5 does, 6 does, infinite numbers. Okay, and like they writing here, we can check it by putting in 4 for y. Is that true? Is 6 greater than 5? Sure. All right, B. To test the temperature rating of a coat, a scientist keeps the temperature below 5 degrees Celsius. Write and graph an inequality to represent this situation. So, below 5 degrees Celsius. Well, it can't be 5 degrees then, right? It has to be less than that. So we see that the inequality symbol is pointing at the T. So we want things less than 5. We can't include 5 in the solution, so it's going to be an open circle. And we're going to take everything to the left of 5, because everything to the left of a number is less than. Let's do some practice ones. Page 324. Write an inequality that represents the phrase, the sum of 1 and y is greater than or equal to 3. So the sum of y and 1 is greater than or equal to 3. Okay, so that's the inequality, right? And now we have to check to see if y equals 1 is a solution. Well, let's put 1 in for y. Let's substitute 1 for y. And let's check to see if this is correct. 1 plus 1 is 2, right? Is 2 greater than or equal to 3? No. So 1 is not a solution. Okay, 1 is not a solution because 1 plus 1 is not greater than or equal to 3. All right, number 5. The temperature in February was at most 6 degrees Fahrenheit. Write and graph an inequality to represent the situation and tell what the variable represents. So here at most, so it could be 6 degrees Celsius, 6 degrees Fahrenheit, or less. It can't be bigger than 6 because it says at most. So 6 degrees is the highest number or greatest value we can have. But all the other answers could be less than 6 degrees Celsius, 6 degrees Fahrenheit. So what does the T represent? T represents the temperature in degrees Fahrenheit. So let's find 6 on our number line. And we're going to have a solid circle because 6 can be included. It says at most 6. So 6 can be included. And we're going to have everything else go to the left because it can't be bigger than 6. All right, let's continue. Number 1, graph 1 is less than or equal to x, and use the graph to determine which of these numbers are solutions of the inequality. And so we have to check to see if -1, 3, 0, and 1 are solutions. So x is greater than or equal to 1. So it can include 1, and it has to be greater than 1. So we have to go to the right. All right, so is -1 a solution? Is -1 less than or equal? Is -1 greater than or equal to 1? This is what we're saying. If we substitute -1, -1 is greater than or equal to 1? No. So -1 is not a solution. Let's substitute 3. Is 1 less than or equal to 3? Yes. So 3 is a solution. 0. Is 1 less than or equal to 0? No. Is 1 less than or equal to 1? Yes. So our solutions are 3 and 1. Okay, number 2. Graph -3 is greater than z. So z has to be less than -3. So we're not going to include -3 because -3 is not less than -3. So we want everything to the left of -3. And check the graph using substitution. Well, let's try -4. Is -3 greater than -4? Yes. Write an inequality that represents the phrase, the product of 3 and x. Well, we represent the product of 3 and x as 3 times x, 3 with the variable right next to the number 3, is greater than 6. Okay, so draw a graph that represents the inequality and check your solution. So here we're multiplying the variable by 3. So we're going to divide both sides of the inequality by 3. And we get x has to be greater than 2. Because 3 times 2 is not greater than 6. 6 is not greater than 6. So 2 is not a solution. So we're going to find 2 on the number line, and it's going to be an open circle because it's not included. 2 does not make a true statement. So we want numbers greater than 2. So we're going to go to the right. Now let's check one of the numbers greater than 2. Let's try 4. 3 times 4 is greater than 6. So we're checking that, right? 3 times 4 is 12. Is 12 greater than 6? Yes. So our solution is our solution is right. X has to be greater than 2. X must be greater than 2. All right, number 4. During hibernation, a garter snake's body temperature never goes below 3 degrees Celsius. Write and graph an inequality that represents this situation and tell what the variable represents. All right, so we have this garter snake. Its temperature never goes below 3 degrees Celsius. So it could be 3 degrees Celsius, right? But it can't go below it. So T has to be greater than or equal to 3 degrees Celsius. So find 3 on your number line. And 3 can be included because that's the lowest temperature that the snake's body goes. And everything to the right would make it true. So all we have to do is substitute, like for instance, 4. Is 4 greater than or equal to 3? Yes. Number 5. Write an inequality to represent this situation. Nina wants to take at least $15 to the movies. How did you decide which inequality symbol to use? All right. So she wants to take at least $15. So D, dollars, greater than or equal to $15. The least amount of money she wants to take is $15. Can she take more? Yeah, she could take 16, 17, 18, 19, so on, right? But she doesn't want to take less than 15. So how did we decide on greater than or equal to 15? Well, first, D represents the amount of dollars she's going to take. Okay. So D is greater than or equal to 15. D represents the amount of dollars. And she wants to take $15 or greater than $15. So that's why we use greater than or equal. All right, 325. Which of the following numbers are solutions of x greater than or equal to 0? So we want anything that's 0 or to the right. Well, that eliminates any of the negatives. Negatives are to the left of 0. So I'm going to cross out all the negatives because those cannot be solutions. Everything else can be a solution because everything else is equal to or greater than 0. So 0, 3/100ths is greater than 0. 0 is equal to 0. 1.5 is greater than 0. And 1/2 is greater than 0. All right, graph the solutions to each inequality checks the solutions. T minus 8, so the difference of some number and 8 is less than or equal to 0. So we see here we're subtracting from the variable, so we're going to add 8 to both sides. And so we have to have an answer that's less than or equal to 8. Less than or equal to 8. So we can put a solid dot at 8, less than or equal to 8. So we want everything to the left. So let's just put in a number. Can we put in 8? Is 8 less than or equal? If we substitute 8, 8 minus 8, is that less than or equal to 0? Well, 8 minus 8 is 0. And 0 is less than or equal to 0. If we put in 7, 7 minus 8, that would give us -1, right? and -1 is less than or equal to 0. So this is correct. Okay, here h is greater than -7. Greater than -7. So -7 won't work, right? So we can have an open line, an open circle at -7, because -7 is not greater than -7. So let's put in -6. Is -7 less than -6? Yes. Any number to the right of -7 will be greater. Okay, x is greater than or equal to -9. So -9 would make it true, and x has to be greater than. So everything to the right would be greater than -9. So is -8 less than or equal to -9? Yeah. Okay. Remember, this closer we get to 0, the greater the number. Or the further we go to the right, the greater the number. All right, 2 times some number, the product of 2 and some number is greater than 5. So to solve this, we need to divide both sides by the 2. That isolates the n. And then we have 5 halves. Well, 5 halves can be written as 2.5. So find 2.5 on the number line. So I see 2, and there's only 2 marks after it, so right in the middle. And it has to be greater than 2.5. I'm going to write it as 2.5. And it's going to be an open circle. So n has to be greater than 2.5. So let's put in 3. Is 2 times 3 greater than 5? 2 times 3 is 6, and 6 is greater than 5. So that checks. Anything to the right will make that true. And finally, x has to be less than 4.5. So here's 4. And so -4.5 would be in between -4 and -5. And it says less than that. So -4.5 will not be a solution. And we're going to go to the left. So is -4.5 greater than -5? Yes. Okay, so everything to the left will make that true. All right, number 12, write an inequality that matches the number line. Okay, so I see an open circle, so the answer does not include 6. And the numbers are all to the right, so the numbers have to be greater than 6. In the next one, the -3 is included. And everything's to the left. So we want x has to be less than or equal to -3. Again, solid circle, we're going to use the equal symbol. Okay, we have an open circle here at 1.5. So we want x to be less than 1.5 or 1.5. Okay, open circle, so 1.5 is not a solution, but 1 is. 1 is less than 1.5. And finally, we have a solid circle at -3.5, and everything's greater than it. So we can say x has to be greater than or equal to -3.5. 16. A child must be at least 48 inches tall to ride a roller coaster. Write and graph inequality represent this situation. At least 48 inches tall. So the child could be 48 inches or taller. So the height of the child has to be greater than or equal to 48 inches. So we could have a solid circle at 48 because if the child is 48 inches, he can ride the roller coaster or she can ride the roller coaster. And then everything to the right would be a true statement. H represents the height of the child. Can a child who is 46 inches tall ride the roller coaster? Well, 46 is to the left of 48. That means 46 is less than. So no. 46 is not equal to or greater than 48. All right, 17, page 326. Write and graph an inequality to represent each situation. Tell what the variable represents. The stock is worth at least $14.50. I don't know. As for stock, at least. So it can be more than 14 and a half. And it can also be equal to 14 and a half dollars. Okay, so S represents stock value. So where's 14 and a half? It's right here. And 14 and a half would make it true, and everything to the right would make it true. The temperature is less than 3.5 degrees Fahrenheit. T is less than 3.5. So find 3.5, and it's an open circle. Why is it an open circle? Because it has to be less than 3.5. 3.5 is not less than 3.5. It's equal to it, right? So we would need anything that's less than 3.5. The goal of the fundraiser is to make more than $150. To make more than $150. So, I don't know, M for money maybe? Greater than $150. So it can't include 150 because again, 150 is not greater than 150. So anything to the right of 150. And M is fundraiser money or money raised. M is money raised. All right, 20. Explain how to graph the inequality 8 is greater than or equal to y. Okay, so we'd find 8 on the number line, right? Okay, it says less than or equal to 8, so we would use a solid circle. Okay, then draw the line to the left. Find 8 on the number line. Use a closed circle. And it has to be less than or equal to 8. So we would draw the line to the left. All right, 21. The number line shows an inequality. Describe a real-world situation that the inequality could represent. So I see 1, 2, 3, 4 lines in between the two whole numbers. So those are fourths. And it's at 3/4, and it's an open circle. I don't know. let's just write F has to be greater than 2 3/4, or 2.75. Okay. Maybe it's baking. And it's the amount of flour that the person needs. Okay. So in this case, the person needs more than 2 3/4 cup of flour. Okay. And 22. Natasha is trying to represent the following situation with a number line model. There are fewer than 5 students in the cafeteria. She has come up with 2 possible representations shown below. Which representation is correct and why? Well, this does show fewer than 5, but I see a problem when we get down to here. How do you have a -1 student? You can't, right? How about this one? Okay, yeah, there could be 0 students in the cafeteria. There could be 1, 2, 3, 4. Yeah, so the bottom one. The line showing only 0, 1, 2, 3, 4. We can't have a negative number of students. All right, so that completes our discussion of writing inequalities. And in our next session, we'll start Module 12. So until then, I will see you soon.